All right, today we're going to talk about permutations. Okay, 12.2. Permutation is a special type of probability that we're going to talk about. A simple definition says that a permutation is when a group of objects are arranged in a certain order. Okay, order makes a difference. So, for instance, these are all different examples of permutations. Okay, the combination of your locker. Okay, now we're going to talk about something called a combination later, and we'll talk about why that's kind of funny that they use the word combination. But the combination of your locker is a permutation because the order matters. If your combination is 1, 2, 3, 4, well, that's a lot different than if you were to try and dial in 4, 3, 2, 1. So the order makes a difference. Batting order in baseball, that would be a permutation. The order you finish in a race. You know, if you have Joe, Jim, and John finish first, second, and third, that's different if you had John, Joe, and Jim. So the order makes a difference. Okay, that's really important. Order matters. So let's just do a real simple example here. It says, how many ways can 3 books be placed on a shelf if they're chosen from a selection of 8? Okay, so you have a pile of books, 8 books. You want to put them up on the shelf. So you have 3 choices. You have choice 1, 2, and 3. Okay, so in that first choice, how many books could you pick? You could pick 8 different ones. Second choice, you have 7. Lastly, you have 6. Okay, and then, so what do? Well, this should feel familiar to the counting principle. You multiply those together. Well, that's 8 times 7 times 6, which is 336. So there's 336 different ways in which you can rearrange those eight books on your shelf. Now you might be asking yourself, well, why are we doing this? That's a lot like the counting principle. You're absolutely correct. It is a lot like the counting principle. Well, we'll get into that a little bit more here in just a few minutes. But here, this is something else that I would like to talk to you about. Says the definition of this, one of the actual definitions of permutation is the number of permutations of n objects taken r at a time is, and it has this, there should be an n right there, sorry, should be this. It said p of nr equals n factorial over n minus r factorial. Well, what the heck does that mean? Well, let's take a look at this example I just did up here. Okay, so up here it says that we have 8 books and we're going to pick 3 from them. So according to this definition, to figure that out, what we could do, and the way you could write it is this. Okay, 8 is the number of objects you're choosing from, so it'd be 8. And R is the number of objects you're actually choosing, so it's 8 choose 3. And so what you could do is this. You could simply just do 8 factorial over 8 minus 3 factorial, which would be the same thing as 8 factorial over 5 factorial, which, as we know, is this would be 8, 7, 6, 5, 4, 3, 2, 1. This would be 5, 4, 3, 2, 1. And all these would cancel. And you'd get 8 times 7 times 6, which is exactly what we did up here. Which would be 336. Now you might be asking yourself, well, why the heck would we be doing all this work when that's easy? 8, 7, 6. Well, what if we were talking about a much bigger example where you had to come up with the number of selections. Let's say you had 100 different things to choose from and you had to put them in an order of 50. Well, nobody wants to multiply 100 times 99 times 98 times blah blah blah. You can use this little simple example. Now the other thing is your calculator will do this for you. Okay, and we'll talk about that in class on how to use your calculator. And it makes life much easier by using your calculator. Okay, let's do another example here. All right, so let's say a baseball team has 15 players on it. The coach needs to fill out a batting order consisting of 9 players. How many different batting orders could he create? So using that new formula that I just gave you, this would be permutation. There's 15 players. We're going to choose 9. Okay, so what that would mean is 15 factorial over 15 minus 9 factorial. Well, that's 15 factorial over 6 factorial. Well, you can take your calculator and do that. If I was using my calculator here, I would do 15 factorial divided by 6 factorial. And whew, get a big number right there. 18162144400. So what is that? That looks like there's 1,816,214,400 different ways he could create that. That's a lot. But that's how you would figure that out. So it makes this little formula right here actually does make life a little easier. You add in your calculator and wonderful things happen. So hopefully that makes sense. That's obviously the goal here. If not, you can always just come to class again and we can go through it. I realize there might be a few questions. Now, let's talk about the next thing, and that is permutation with repetition. So meaning you could go through and you could use the same number over and over and over again. Kind of going back to our example of our combination lock, sorry. You could use, if you want to use the number 4 3 different times in your combination lock, okay, that would be an example of a permutation with repetition. But when we do that, okay, nice little formula for us. It says the number of permutations of n objects of which p are alike and q are alike. Okay, we have this formula right here. Now this little dot 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 is something I'll talk about here in just a few minutes. But let's do an example and hopefully this will make sense. It says how many different ways can the letters of the word parallel be ordered? All right, well, let's see. So if I'm looking at our example here, okay, it has n objects of which p and q are alike. So of the word parallel, we have 1, 2, 3, 4, 5, 6, 7, 8 words, or pardon me, 8 letters. So we have 8 objects. Okay. Of that, okay, how many of them are alike? Well, A, we have are alike. Okay. So we have 2 A's, and then we have 3 L's. So how do I use this? Well, what I do is this. Pretty simple. I do 8 factorial, and then I divide by all the numbers that are repeating. So I have an A that's repeating twice, so I would do 2 factorial. And then I have an L that's repeating, so I would do 3 factorial. Okay, and then I would take my calculator and I'd figure that out. So I would just do 8 factorial divided by, I'm going to do parentheses because there's 2 of them down here. 2 factorial, 3 factorial. And what I get? 3360. Oops, sorry. 3360. Okay, not terribly difficult. Now, why do I have this little dot dot dot? Because that means that if there's more than just 2 letters that are repeating, then you need to just keep adding those in. So for instance, what about this word, knick-knack? Okay, that's a good word, knick-knack. Okay, knick-knack has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So 10 total objects. So that would be 10 factorial divided by, all right, so what do we have? We have K's that are repeating. 1, 2, 3, 4 K's. 4 factorial. I have N's that are repeating. 1, 2. 2 factorial. I have C's that are repeating. 1, 2. Okay, anything else repeating? We got the K's, we got the N's, we got the C's. I is not repeating. A is not repeating. Okay. So take out the calculator. Let's try that. 10 factorial divided by parentheses 4 factorial 2 factorial 2 factorial, and what do we get? 37,800 100 different ways that you could arrange those letters. Okay. So hopefully that makes some sense. So if not, just kind of file away the question, and we'll talk about that again. And we'll also get into greater detail about the rationale or the reasoning behind this in class as well. All right, last one that we're going to talk about. Okay, it's circular permutation. Okay, circular permutation says if n distinct objects are arranged in a circle, then there are n minus 1 permutations of the objects around the circle. Okay, so for instance, oh, that's not a bad circle right there, freehand. It says there's 5 cupcakes in a circular pan. How many ways can these be arranged? So let's say we have 5 of them. Let's see. So it's 1, 2, 3, 4, 5. Okay, so it's just simply being asked, how many different ways can you arrange these things in a circle? So meaning, if you start here, so there's 1, 2, 3, 4, 5. Okay, that's one way. But what if I started here? What if I started here? Okay, and so that's what it's referring to, is when you're going circular, eventually you're going to start repeating yourself. So very simply, you're just going to do n minus 1 factorial. Well, in this case, there's 5 minus 1 factorial. So it's 4 factorial, which we all know is 4 times 3 times 2 times 1, or 24. That's it. Okay, it's not horribly difficult. Actually quite simple, so hopefully that's an easy one for you to have memorized. So that's a lot of different stuff. We went through just some of the basic permutation. We went through permutations with repetition as well as circular permutation. So we'll obviously do a lot of examples in class, but as always, if you have some questions, make sure you kind of make note of them, and we'll talk about them when we see each other. Thank you.